Hello guys, welcome to the fifth session, Java Object Oriented Programming. In today's session, we will learn about introduction, object, class, inheritance, overriding methods, interfaces. Introduction. An object oriented program consists of many well encapsulated objects and interacting with each other by sending messages. If you look at here, these boxes like name, attribute, behaviors. So this is one object. Okay, this is one object. So like this, we have multiple objects. Okay, and these objects interact with each other using these messages. And every object has name, and it also has attributes and behaviors. Okay. Object-oriented language focus on components that the user perceives with object as basic unit. Benefits of this object-oriented language is in software design, is in software maintenance, reusable software. So we can design software easily, and maintenance is also easy, and we can use these objects in other implementations. As an example, if we write a computer soccer game, okay, in object oriented programming, we represent every real thing in the form of an object. Suppose if we take this soccer game, so in soccer game, we will have a players, ball, field, referee, audience, weather, scoreboard. So these are the real time entities. So in these real time entities, we represent in the form of object. If you look at here, player, ball, field, referee, audience, weather, scoreboard. So and each and every entity has some properties. Okay, and how we will mention those properties in each object. Okay, object. So what is the definition of an object? These objects are key to understanding the object oriented technology. Examples of real world objects like dog, desk, television, bicycle. So these are all objects. Okay, it has two characteristics. One is state, and another one is behavior. So like if you take a dog as an example, okay, it has a name, color, breed, okay, hungry. So these we call it as a state, and dog can bark, and a dog can fetching and wagging tail. So these behaviors, so we call it as behavior. Okay, so if if we take a dog as an example, their feature, it has a state and behavior like this. Okay, and what is the benefits of object? Modularity. Source code of an object can be written and maintained independently of the source code of other objects. Okay, once created, an object can easily passed around inside the system. And next, information hiding. By interacting only with the object's methods, the detail of internal implementation remain hidden from the outside world. If you look at here, the name, color, breed, okay, so we need not to expose the state of that particular object to the external world. So you can provide some additional methods like what is the color. So you can mention get color, and if they create an object of that dog, then they can get an object of color of that particular dog. Okay, so they other client applications, external world applications cannot directly access the state of particular object. And code reuse. If an object exists, you can use object in our program. And pluggability. So if a particular object turns out to be problematic, we can simply remove it from our application and put it in different object. We can plug in the different object. Okay, next, class. In the real world, you'll often find many individual objects of all same kind. Okay, there may be a thousands of other bicycles in existence. Okay, all of the same make and model. Each bicycle was built from the same set of blueprints and therefore contains the same components. So like if we have similar kind of dogs, okay, or similar kind of bicycles. So those we can represent in the form of a class. In object oriented terms, we say that our bicycle is an instance of a class of object known as bicycles. A class is the blueprint from which individual objects are created. Okay, so if you look at here, bicycle is a class name and it has states cadence, speed, gear. Okay, and change cadence, change behavior, change gear, speed up, apply brakes. So these are behaviors. Okay, and these we call it as states. Okay, so so we can create n number of objects using this class. Okay, let me give an example on class and object. Okay. Here we have created class A, okay, which has variable integer A equals to 5, which is having private access specifier, and it has one method public void display integer B, okay, and it prints one statement A and B. Okay, so here if we take class A, so class A has one state called A variable, okay, and it has one behavior display. So how we can create an object of this particular class? This is a blueprint of an object. Okay, blueprint of an object. So I have created one more class called test here, and which is having one main method. So how we can create an object of a particular class? So this is class name A, and this is object. Okay, A is equals to new A, and so whenever we wanted to access any behavior of a particular object, then we have to use object name dot that behavior, that method name. Okay, a dot display of 3, and we cannot access the private access specifiers. So if we want to use a directly a variable, okay, a dot a, I cannot, because I'm not able to identify a from a class. Okay, so this is how we will create an object. So in previous slide we discussed like bicycle is a class. So in bicycle we have that cadence, gear. So these are the state, and apply gear, okay, change cadence. So these are the behavior. So in similarly here we have created class A, which is having one state called A, and one method called display. Okay, so like this, if you run as Java application 5 and 3, so here if you look at here, it prints 5 and whatever the value b we are passing, that one. So we can create n number of objects. So what we can do here, again class name a1, you can create n number of objects. So new a1 dot display 8, run as Java application. So 5 and 3, 5 and 8. So these a1, these are of type class A. So class is one, but we can create n number of objects, and which can have different state and behavior. Okay, we'll go back to the slide. Okay, so bicycle, cadence, speed, gear. So this is the states and behavior. Next concept is inheritance. So different kind of objects often have a certain amount of common with each other. Okay, and mountain bikes, road bikes, and tandem bikes, for example, all share the characteristics of bicycle. So if bicycle is one class, and we can have different kinds of bicycles like mountain bikes, road bikes, tandem bikes. So what is the common property of bicycles? Like speed, okay, gear. So these are the common for bikes, and each and every special bikes, they have some additional characteristics, okay, behaviors. So if you look at here, mountain bikes, road bikes, and tandem bikes, these all share the characteristics of bicycles like speed, pedal cadence, current gear, and also defines an additional features which make them different. So mountain bikes may have some additional characteristics, okay, from the normal bikes. In the same way, tandem bicycles have two seats and two handlebars, whereas road bikes have drop handlebars, whereas mountain bikes have additional chain ring, giving them a lower gear ratio. So, if bicycle is one main class which can have common properties like speed, pedal cadence, gear, okay, and these specific bikes like mountain bikes which can have additional chain ring, tandem bikes can have two seats and two handlebars, whereas road bikes do not have handlebars. Okay, this object-oriented program allows classes to inherit commonly used state and behavior from other classes. Okay, so here bicycle is superclass. From this bicycle, what are the properties? Speed, gear, cadence. These are the common properties for bicycle. And in mountain bike, we can have additional chains, whereas in road bike, tandem bike, two seats and two handlebars. So these specific bikes can have additional characteristics along with the common characteristics. Okay. So how we will implement this inheritance, this common characteristics, how we can get these common characteristics from parent classes. So so how we can write, like if we have bicycle as a one class, so we can define mountain bike like this: class mountain bike, okay, which uses extends keyword. So if you want to inherit any properties from particular class, then you will have to use extends keyword and that class name. So if you want to extend some characteristics from bicycle, then use the parent class name. So this is class mountain bike uses the extends keyword and the parent class, and you can define new fields, methods that this particular subclass can have. Okay, extend keyword is used to create a subclass from main class to inherit the properties of main class. Okay, so let me give an example on inheritance, like how to create a inheritance in Java. Okay, we will use the previous example only. Here we have one class A which has variable A which is having value as 5 and one display method, okay, public void display with integer parameter, and which prints the A and B value in that method. Okay, and now we have created one more class called B which extends A. So now A is superclass whereas B is subclass. Okay, so B can inherit the properties of class A. Along with the class A properties, we have defined these additional properties like B equals to 3. Okay, integer B equals to 3, and which is also having one method called public void show, and it has system.out.println B. Now using subclass, can we get the superclass properties? Okay, super can we call the superclass methods? Because we discussed that you mountain bike can have the bicycle characteristics. In the same way, B class can have A characteristics. How, we will see. Okay, so in class test, what I'll do, I'll create a B object. Okay, so to create a B object, how we can create an object? Class name and identifier B equals to, okay, B object new B. Now B object dot show. So what it does, B in B class, what do we have? We have one show method. Okay, so if you run it Java application, it prints the 3. Okay, so using a subclass also we can get the its superclass characteristics like A method. So B object dot display 4. Okay, so this is not B class method. This is class A's method. Displays class A method. See, if you look at here, we don't have display method in class B, but it has in class A. But this class B extended class A. So that was the reason we are able to use display method of its superclass. Okay, if you look at here, run as Java application 5 and 4. So like this we can inherit some properties of its parent classes. Okay, next, inheritance hierarchy. In Java, a class can extend only one class. In our example, we have class B which extended class A. Okay, so if we have another class called C, we cannot extend A and C together in class B. So only one class can have one parent class. Okay, in Java, a class can extend only one class. It can have only one immediate superclass. This kind of inheritance we call it as single or linear implementation inheritance. The inheritance relationship can be depicted as an inheritance hierarchy. Okay, so here if in Java superclass is object. Okay, this is the top class, and object is light is extended this object class. Okay, subclass of object is light, and light is extended to light bulb, and light bulb is have a subclass spotlight bulb, and this light is having tube light, neon light. So but this light bulb is not extended tubeless. See, we cannot extend more than one class to any class. So only light bulb is extended to light, and tube light is also extended to light. Okay. So in Java, we can extend only one class. So this is called single or linear implementation inheritance. Okay, and this inheritance hierarchy, okay, in this we have two different types of relationships. One is easier relationship and hazier relationship. In easier relationship means inheritance defines the superclass subclass relationship. So if we take class B class A example, so B extends class A. So here A is a superclass, B is subclass. This relationship we call it as a easy relationship. Okay, B is a A. In previous example, like if you take the previous example, spotlight bulb also, their spotlight bulb class is an object of class light. So this is known as easy relationship. Whereas has a relationship, in has a relationship, we can create an object in a class. Okay, so suppose if we have class A, okay, in class A we have defined integer A, right? And class B extended class A. Instead of extending, we can also write variable as, I mean, we can enclose that another class object. Okay, I'll give you an example how we can define has a relationship. Okay, I'll show you. I have created one more class called C. Okay, in C I have declared A, and here I have used this A variable. See here in show method, A equals to new A. I have created an object of A and A dot display of 4. So now if I go to C here, C equals to new C dot show, run as Java application 5 and 4. So if we observe here, what we did, B extended A, okay, and so here B is a is a relationship here, and here if you look at here, B object dot display. So from this we can call the A superclass method, whereas in C, instead of extending, what we did, we included. So has, C has A, so we used as a attribute, okay, as a variable A, and here A dot display, that variable we have used in our method, so which is has a relationship. So this is how we differentiate is a and has a relationship. This is also known as aggregate, okay, this is also known as aggregate. So aggregation defines has a relationship, also called as whole part relationship between an instance of a class and its constituents. Okay, and this is how we'll use. If you take an employee and department, employee is a main class, and which we can include a department in employee. Okay, next, overriding methods. So if we have any particular method in superclass, and if you want to, you know, make change or implement in subclass differently, then you can override those methods. So overriding a method allows subclass to provide its own implementation within the method. When the method is invoked of an object of subclass, it is the method implementation in the subclass that will be executed. If we take our previous example like display, okay, in class A we have a method called display, whereas same method we can implement in class B as well, and you can write your own implementation. So we will see how it works, okay, and what are the behaviors of this overridden method, I mean, like, what are the rules that we need to follow when we write override methods. Okay, the new method definition must have same signature, that is method name, type, and number of parameters. Okay, and also the return type of overriding method can be a subtype of return type of overridden method. We will see how it works. Okay, the new method definition cannot narrow the accessibility of the method, but can widen it. The new method definition can only throw all or none or subset of checked exceptions. So we will see these rules, how it works when we create these overridden methods. We will go to the, we'll create a class and see how it works. Okay. If we look at this particular class A, which has display method system.println, A is display method. Okay. So what we will do, and B extends class A, and which is having show method. Okay. First of all, I have commented this display method. Now, so B extends A. So B is a subclass of class A. So B can inherit the properties of its superclass. So what we are going to do is B object dot show, B object dot display. So if we run this one, 3 shows a statement, and display method. Yes, display method. Okay. Yes, and I'll change here dot display. Okay. Now, so we can override methods and we can give our own implementation in subclasses. So what I'm going to do is, here I have created one same method display. Okay. However, we have written this way. A class A public void display. In the same way, in class B also here public void display system out println this display method. Now, if we create a B object, which method will execute? Will it execute class A method or class B method? It will execute class B method because we have created an object of class B. So that's why we'll get class B's object. If we don't have any implementation of superclass method, then we will get superclass method statements. Whereas if we have any statements, if we override that method in subclass, then subclass method will execute. Okay, and now if I change something here, okay, if I see here, return type should not change, so method signature should be same. Okay, public void, and now integer a. So parameters wise fine, but here return type should not change and throws exception. See, we should not throw any exception. So this is also, these are the rules which we discussed in previous slide. Okay, and private. So we cannot narrow the accessibility. So in a class we have it as a public. So here it should have, it should be private. Suppose if we have private here and here public, this should be fine because we are widening the accessibility, not narrowing down. So these are the rules which we discussed in previous slide. Okay, so this is the chart which we discussed. I mean, like whatever we have written the code, that's what here we have mentioned in the slide. So method name must be the same in overloading. Yeah, so what does it mean by overloading? So overriding, what we discussed in overriding, we are writing the same method in subclasses, whereas overloading means within the same class with different arguments. Okay, so within the same class you can have the same name but different implementation. Okay, that is known as overloading. Okay, that is known as overloading. If you take an example, real-time example, like moving an object from one place to another place. Okay, if if moving is one behavior, okay, for snakes we call it as a crawling. Okay, for men, humans, for human it's walking, birds flying. Okay, so these three different classes have different names. Okay, but the behavior is same. So in method overloading what we'll do is we'll have the same method name but which can have different arguments. Okay, let me give an example on method overloading. See here, this display method, right? Public void display integer a. So same name with different arguments. Integer a, integer b, two arguments. So you can give n number of arguments parameters to method names. Okay, so you can write your own implementation. This is known as method overloading, whereas method overriding is in class a we have defined the same name, signature should not change, whereas overloading signature should change and it should be in the same class. So this is known as method overloading. So here, method name must be the same. In overloading, must be the same. Argument list must be the same. In must be different. Return type can be the same. Here in overloading can be different. Throws class must not throw checked exceptions. Can narrow exceptions thrown. Whereas overloading can be different. Accessibility can make it is less restrictive. Whereas overloading can be different. Declaration context, a method can only be overridden in a subclass, whereas a method can overload it in the same class or in the subclass as also. method called resolution. The runtime type of object referenced the runtime determines which method is selected for execution. So whatever the object we create, based on that object, that particular method will be executed. Whereas overloading at compile time, declared type of or reference type is used to determine which method will execute at runtime. Next concept is interfaces. An interface is a reference type in Java. Okay, it is similar to class. It is a collection of abstract methods. So if you look at class A in previous example, we have defined methods, right? Display, show. Okay, in class B. So these methods we already implemented. Whereas if you don't know the implementation, or if we freely, I mean, like if subclasses want to implement that particular method, then we can write those, we can make those methods as an abstract and declare them in interfaces. So an interface is a reference type in Java. It is similar to class and it is a collection of abstract methods. Using classes we can build only single linear implementation, whereas in interfaces you can extend multiple interfaces, um, as we already discussed. Whereas in classes we cannot extend multiple classes, right? But in interfaces we can extend n number of interfaces. Okay, so and each interface has abstract methods and constant declarations, nested class declarations, okay, or nested interface declaration. So this is the syntax: accessibility modifier, interface, interface name, extends, interface class. Okay, an interface does not provide any implementation and therefore abstract by definition. Abstract. So interface is an abstract by definition. This cannot be instantiated. So because you don't have any implementation in the methods, so whoever extend these interfaces, they have to implement the definition of their particular abstract methods, and you can create an object of classes not for interfaces. Okay. So an abstract method declarations, an interface defines a contract by specifying a set of abstract method declaration but provide no implementations. Let me give an example on interfaces. Here I have created bike interface. So how we will create an interface? Public, it starts with interface keyword. Okay, interface and bike, interface name. Okay, and it has only abstract methods, so we do not have any implementation. So if you look at here, method signature public void displays, here it's ended with semicolon, so we cannot implement methods here. So if you try to write something, it throws compile time exception, so we cannot write anything. So so just declare methods, abstract methods. So subclasses can extend these interfaces. So if you look at here, mountain bike implements. So classes uses extends keyword to extend. Okay, whereas these, if you want to extend any interfaces, you have to use implement keyword. Okay, mountain bike implements bike, and it has public void display. So you have to override this method, interface method bike display. Okay, system out dot println mountain bike here. And in test class, what we'll do, can we create an object for interfaces? No, we cannot create an object for interfaces. So only we can create an object for subclasses. Okay, so here new mountain bike. See, interfaces can be used as reference. This is called a reference. So we are using it as a reference, but not for creating an object. So you can create objects of its subclasses, but you can refer them. Okay. Now here b dot display, run as Java application mountain bike. So interfaces can be referenced but cannot be instantiated, and it has only abstract methods. Subclasses has to override. Suppose if I don't override this display method, what will happen? Okay, and public void show. So see here, if we don't override, if you are implementing any interface and if you don't override its interface methods, then it will throw an exception. Either you have to make this class as an abstract, or you have to implement the abstract methods, because we cannot, I mean, like, leave those methods unimplemented. So we have to implement those methods. Okay, or else you have to make these classes abstract, so you cannot create an instantiation of this particular class. Okay, so what we'll do here, I'm overriding that method. Okay, so an interface defines optional return type method name, and it can throw an exception. So as we are already discussed, like interfaces can be implemented. So a class specifies the interface, it implements comma separated. So classes cannot be extended, multiple classes cannot be extended, whereas implements can be implemented or extended. Okay, so we can use multiple interfaces to any particular class or to particular interface, and also we can extend the interfaces. And we are also discussed about interface reference. So bike, b equals to new mountain bike. So we used interface name as a reference to create an object of subclasses. Okay, next, constant interfaces. So these interfaces can be used to declare constants as well, like public static final integer speed 10. So this is constant. These are the constants. And what we can do, these constants can be directly used. So here public start mine b dot, like, bike dot speed. So system dot println. So constants can be accessed directly by interface name dot that constant name. If you look at here, see here, speed is 10 and mountain bike. So interfaces can have constants and abstract methods, and subclasses has to override those abstract methods. Otherwise, you have to make those subclasses as abstract classes. Okay. If you have any queries on today's session, please mail us at info@vicourses.com. We are happy to answer our queries and questions. Thank you so much.